Hi, I'm Mark Warner, and I'm the project manager on the Daniel K. Inouye Solar Telescope Project, or DKIST as we often call it. I'd like to take a few minutes to tell you about our telescope and where we currently are in the process of completing construction and beginning operations. Let's start with a quick recap of what the project is all about. As you may know, the DKIST project is a 10-year-long, $350 million effort to design, build, and commission what is now the world's largest solar telescope. I say 10 years, but we're actually in the 11th year right now. This is because of delays caused by the COVID pandemic, which I'll explain in a few minutes. In the meantime, just note that we're getting very close, within a few months in fact, of completing construction and handing the facility over to operations. If you look at the image on the left, you'll see an artist's cutaway view that was created very early in the project to show what it was that we were going to build. The view on the right is one from just a couple of months ago, and while it's not a cutaway view, you can see that we have completed the outside buildings of the facility, and in a moment I'll show you some of the interior views of the telescope itself. But for now, the bottom line is that we're wrapping up the project and expect to be completed by the fall of this year. The facility itself is located on the 10,000-foot summit of Haleakala on the island of Maui. Those of you that have been to Hawaii know that it's in the very middle of the Pacific Ocean. The site is literally one of the most remote places in the world, which, combined with the elevation of the site, results in excellent scene characteristics and very dark and very clear daytime skies that are ideal for solar astronomy. The facility itself is comprised of a large support and operations building, capped by a rotating enclosure or dome that surrounds and protects the telescope. As I showed you in that first set of photos, these buildings and the dome are well complete. Now let's take a little closer look inside. Up inside the dome is the Altaz telescope mount, with its 6 mirrors that can track the sun and collect and focus sunlight. And down below is a Kudai Rotator, or lab, which has 3 more large mirrors and then a series of precision beam splitters that feed sunlight to the scientific instruments mounted on top of the rotator. Here's a recent view of the telescope mount inside the dome. As you can see, the largest mirror in the optic train is over 4 meters in diameter. This is the primary mirror, or M1, and it's a highly sophisticated off-axis mirror arranged in a Gregorian configuration. The sunlight captured by this large mirror is concentrated onto a spot the size of a quarter at the prime focus location. There, a heat stop removes most of the 12 kilowatts of power that the primary mirror collects, allowing visible and infrared light to pass through. From there, sunlight is reflected off a concave off-axis secondary mirror and then relayed through a series of smaller optics downward through the facility. The image in the lower right shows the mirror team with a freshly illuminized primary mirror before it was reinstalled into the telescope. And the image in the upper right shows the mirror mounted in its cell going back into the telescope. And then, of course, the photo on the left shows the telescope mount itself during its very first on-sun observation test. To give you a sense of scale, if you look closely, you can see a couple of workers standing behind the telescope in this lower left photo. DKIST really is the world's largest solar telescope. The sunlight gathered by the 6 mirrors of the telescope mount is fed down a long vertical path to the Kudai Rotator, which is located inside of a clean room environment. The rotator itself is 16.5 meters in diameter and, as the name suggests, physically rotates about a vertical axis over the course of an observing day. 3 large mirrors located on the Kudai Rotator redirect and further condition the sunlight into a horizontal beam. From there, a series of optical beam splitters divide the sunlight into different wavelengths to feed a suite of 4 scientific instruments that are mounted on optical benches on the rotator. These 4 first light instruments are included in the scope of the DKIST construction project, and all have now been delivered and installed into the facility. These instruments provide a very wide range of scientific capability, from the visible wavelengths to the near-infrared. The first instrument, the Visible Broadband Imager, or VBI, is now nearly fully commissioned, and as I'll show you in a moment, it was used to achieve an amazing first light milestone in early 2020. The second instrument in the construction queue is the Visible Spectropolarimeter, or VISP for short. This instrument was designed and built by the High Altitude Observatory in Boulder, Colorado. The VISP is nearly complete, passing all of its acceptance tests on the mountain, and will next be undergoing its final science verification testing next month. The remaining 2 instruments, a diffraction-limited near-infrared spectropolarimeter, or DL-NIRSP for short, and a cryogenically cooled near-infrared spectropolarimeter, or cryo-NIRSP, were designed and built by the University of Hawaii's Institute for Astronomy. All of these instruments are installed and are now being brought online for testing in the next few months. When fully operational and commissioned, this suite of instruments will allow groundbreaking science to be achieved, including a much deeper understanding than ever before of the magnetic fields that control the dynamics of the sun. It's an exciting time for us on the project as we wrap up this commissioning work and start to see the first scientific data to be delivered from the facility. Which brings us to the schedule and COVID. The DKIST project was formally kicked off back in 2010, with site construction beginning a couple of years after that with groundbreaking and the start of major earthwork. The plan was to complete construction and hand over the facility to operations in late September of last year. And we were fully on track to do just that, but then the pandemic hit. A year ago, in March of 2020, we temporarily shut down all construction activities at the site for a period of nearly 3 months. By the summer of 2020, however, we did resume site work, but in a much slower and less efficient mode of work than originally planned. That said, despite all the challenges of COVID, the construction team has continued to make steady and excellent progress. We're now on track to wrap up work and hand over the facility to the operations team by mid-November of this year. Following that, the ops team will begin a period known as the Operations Commissioning Phase, or OCP, which in turn will lead to full and continuous science operations of the observatory. The COVID-caused project delay is the bad news, but I do have a couple of really good news items to share too. First is just how well the telescope already performs right out of the box. In January of last year, we achieved a spectacularly successful first light milestone using the VBI instrument on the telescope. You might have seen some of these first light images, which were featured prominently in many scientific and mainstream publications and news stories, including landing on the front page of the New York Times itself, above the fold no less. Right from the start, without all of its thermal control systems working, without optimization of the instruments or software systems completed, DKIST has already produced high-resolution detailed images of the surface of the Sun that have never been achieved or seen before. Since then, we've published some other amazing images, including the detailed sunspot image shown here on the upper right. And with DKIST spectropolarimetric capabilities just starting to come online now, with the CryoNIRSP, DLNIRSP, and the VISP instruments, we expect to see more groundbreaking data continue to arise from the DKIST observatory. And the other item of good news is the recognition of just how incredible this DKIST team has been and how hard they have worked, especially through this past difficult year of COVID. All of the amazing progress and now demonstrated capabilities of the telescope is due in large part to the skill and dedicated team we have working for us. A project is only as good as the people implementing its plan. These are the folks that design the equipment, build the parts, turn the wrenches, and troubleshoot all of the issues as they arise. DKIST has, in my opinion, the world's best scientists, engineers, technicians, and support personnel working together to create this next step forward in solar astronomy. Over the next few months, these incredibly hardworking individuals will put the finishing touches on DKIST, and groundbreaking scientific output from the world's largest solar telescope will begin in earnest. My hat is off to this amazing team we've had working for us during this project. Thanks to them, and also thanks to you for all of your support throughout the years. Thank you, and cheers as always.